Okay guys, so today we're going to look at drawing graphs of functions again, but particularly we're going to look at drawing the graph of a quadratic function. Now just like drawing the graph of a linear function, when doing the quadratic function graphs, first you need to get a table of values, get your points and put it on the graph, and then you connect it, right? Now, like we know from before when we did factorization of quadratics, we know the general form of a quadratic is ax squared plus bx plus c, where a, b, and c are constants, right? So we have two examples. So for example, we have f of x is equal to x squared plus 2x plus 1, right? You see the highest power of x is 2, right? So that's how we know that it's a quadratic. Then we have another one. F of x is equal to negative x squared plus 2x plus 2. The highest power of x again is 2, so it's a quadratic, right? So, well, in our last video, we discussed that when we're drawing a linear function graph, we would get a line, right? When we're drawing the graph of a quadratic function, you're going to always get a curve. If you're not getting a curve, you're going to have to check your working because there's probably a little error somewhere, right? So to kind of go through the entire process, we will look at this question, right? So this is an example. So we have this function, f of x is equal to x squared plus 2x plus 3, right? So the first thing that they're asking us to do is complete the table. So what you're going to realize is that when you're doing the quadratic functions, most of the time they will give you a table to complete. Okay, so they give us negative 3, negative 2, 1, 0, 1. So they want us to fill out the y value. So we're going to start with the f of x function. So I'm going to write the f of x function here. Right, so the f of x function is this 2x plus 3, right? So the first one they want, okay, so before we even do that, let's just write it back in terms of x and y, right? Remember we said instead of f of x we could write y, right? So the first x value that they have here is negative 3. So to find that out, we're just going to substitute negative 3 in here. 2 by negative 3 plus 3. We're going to put this into our calculator, right? Let me put that into my calculator. Okay, so when I put that into my calculator, I am getting I'm getting 6, right? So I'm going to fill in that number right there. Then I'm going to stick in a 2, so when x is equal to 2, I'm going to put y is equal to, and where I see an x, I'm going to stick in a 2, right? So it will be 2 squared, negative 2, my bad. Negative 2 squared plus 2 times negative 2 plus 3, right? So anyway I see a x, I stick in a negative 2 instead, run that through a calculator, and I'm seeing positive 3, right? So then so I'm going to put this here. Then the next number that they have is negative 1. So we're going back here again. When x is equal to negative 1, so y would be negative 1 squared plus 2 by negative 1 plus 3. Run that through your calculator again. Now I'm getting 2. So I'm going to stick in a 2. You're going to do the same for 0 and 1. You're going to stick that, substitute them. And so I already did the working for it, right? So I'm just going to take my working. I got a 3 and I got a 6, right? Okay, so if we look at it, our first point would be negative 3, 6. Then we have negative, so let me put a negative 3, 6. Then we have negative 2, 3. then we have negative 1, 2, then we have 0, 3, and last we have 1, 6. So there we have 1, 2, 3, 4, 5. We have 5 points. Okay, so we're moving on now to part B. Now this is how a typical question would come. So part B now is to draw the graph of our function. So this is simply to take our points and put it on graph paper. Now if we look at the points that we have, the type of numbers we have, the greatest number that I'm seeing there is 6. So you don't need a big graph with numbers like 20 and stuff like that. Now if you do that, it's not wrong, but you don't really want to put out such a big graph. So you could space out your numbers in such a way that the highest number that you get in is 6, right? The lowest number that I'm seeing is negative 3, so probably you could go 6, negative 6, right, on both axes, or it's up to you basically, right? So once it'll give you a scale, it's up to you, but sometimes they would give you a scale. So I am going to do that and then we'll continue. Okay, so what I did here was to put my points on my graph paper, right? So let's just recap it. The first one is negative 3, right? So it's negative 3, and it's going to 6, right? So negative 3, 6. Then I have negative 2, 3, negative 1, negative 1, 2, that's supposed to be. Okay, so I'm going to change that one. So that one actually is supposed to be negative 1, 2. Alright, so I changed it, right? That's supposed to be negative 1, 2. That was my bad. Then I have 0, positive 3. And then my next point is 1, 6. Alright? Okay, so the next step basically is to connect your lines. So if you notice, I am not actually using pen and paper for this, right? So I actually have like this software thing on my tablet that I'm using, right? So that's why I got the curve so nice and smooth. So what you need to do is do it on your graph paper. Take your time and get it as smooth as possible with your pencil, right? So if you look at it here now, this is a nice smooth curve, right? So we're going to go on to the next question. So the next part of the question. So part C of the question asks us, does your graph have a maximum or a minimum point? Now, let me just show you something. So here on my paper, graphs shaped like that has a highest point, has a maximum point, right? So the highest point is called a max point. However, graph shaped like this, this have a lowest point. The lowest point is called a minimum point. Okay, so looking at our graph, we have a lowest point, and the lowest point is called a minimum point. So to answer that question, so C, does your graph have a maximum or a minimum point? We have a minimum point because you see that our lowest point, and they want you to state what our minimum point is. Okay, so we have a minimum point. So we're going to look at it. If you notice, that'll be this point down here. So if we read off the coordinates, our x, it lines up with negative 1 on our x. So we're going to write that negative 1. So let's go and check out our y number now. So it lines up with negative 1, but if we go across here, it lines up with positive 2. So our y number is positive 2. Alright, so we have a minimum point that is negative 1, positive 2. Okay, now the next thing they're asking, so part D now, they're asking us to state the y-intercept. Now, the y-intercept of a graph is where the graph cuts the y-axis. Now, remember, if you recall, The y-axis is this one, the one that runs up and down. So where does the graph cut the y-axis? At what number? It cuts it at this point here. This little point here. Right? And what number is that there? That's at number. Let's look at it closely. What number is attached to there? I don't know if you're seeing that clearly. It's a number 3. Right? So it's cutting the y-axis. It's cutting this black line at number 3. So state your y-axis. Your y-intercept. Your y-intercept is 3. That's the answer. And the next question is to state your axis of symmetry. Now, we know if we have a symmetry will be a line that runs through a shape that if, you fold the shape along that line, it will fold directly in half and it will lap half and half, right? So if you have to fold this so that it folds directly in the middle, that would be a line going down here, right? So it will be the line x. So this one will be the x number. X is equal to -1. So y-intercept is x is equal to -1.